Welcome to this 2022 VCAA Specialist Math exam paper series. The exam paper 1 comprises of 10 questions where students are not permitted to bring technology or notes into the examination. The exam paper 2 comprises of 20 multiple choice questions and 6 extended response questions. Students may use approved CAS technology in exam paper 2. In exam paper 1, key improvement areas are probability, basic algebra skills, including how to use trigonometric identities. In exam paper 2, students need to improve on their reading and ability to respond to all aspects of questions. For example, understanding the local behavior of inverse trigonometric functions, and working with random variables that are functions of other variables. Welcome to the first part of VCAA Specialist Math 2022 exam paper. In this video, we will present exam paper 1, questions 1 to 4. Generally speaking, question 1 was answered well, with most students recognizing the need to complete the square in part A. While some arithmetic errors were observed, students could either use the result from part A or use the quadratic formula to find the solution to the equation. Question 2 was answered well, with most students recognizing and attempting to solve the separable differential equation. In question 3, part 1, many students did not find the correct approach to calculate the standard deviation and so were unable to evaluate the required probability. In question 3, part 2, over half of the students correctly used the formula from the formula sheet to present the required confidence interval. In question 4, many students failed to use the partial fraction or other algebraic techniques to simplify the integrand. In addition, some students did not include absolute value signs in the logarithmic term or failed to include arbitrary constant in their answer.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Math 2022 exam paper series. The first exam paper consisted of 10 short answer questions, while the second exam paper consisted of 20 multiple choice questions plus 6 extended response questions. As for exam 1, we separate 10 short answer questions into 3 videos to explain them in details, and hope you will find some help from these videos. In this video, we will present questions from 1 to 4 of exam 1 2022 paper. As it can be seen, question 1 provides a quadratic function where z is a complex number, and it contains 2 parts of questions. In part A, the question is to express the quadratic function in the form of z plus ai, or in parentheses squared, plus b, where both a and b are real numbers. Part B is to find the solution of the equation p of z equals 0. Now let's come to part A of this question. Since pz equals z squared plus 6iz minus 25, which can be written to z squared plus 6iz plus 3i, or in parentheses squared, plus 9 minus 25, which equals z plus 3i, or in parentheses squared, minus 16. As it can be seen, we apply the completing square technique here. Now we move on to part B, which is going to solve the equation p of z equals 0. Since p of z equals z plus 3i, or in parentheses squared, minus 16, which comes from part A. According to the formula of the difference of two squares, it can be factorized to z plus 4 plus 3i, or in parentheses multiplies z minus 4 plus 3i, or in parentheses, which equals 0. After applying the new factor law, we obtain the solution of this question. Z1 equals 4 minus 3i. Z2 equals negative 4 minus 3i. Question 2 is to solve the differential equation dy over dx equals negative x times square root of the result of 4 minus y squared, and then find its primitive function y equals f of x, given that y of 2 equals 0. Since dy over dx equals negative x square root of the result of 4 minus y squared, which gives dy over square root of the result of 4 minus y squared equals negative x dx. Then we integrate both sides of the equation, and based on the integration formula of arcsine function, the integral of 1 over square root of the result of 4 minus y squared with respect to y equals arcsine of y over 2. Hence, the integral of 1 over square root of the result of 4 minus y squared with respect to y equals arcsine of y over 2, which equals negative x squared over 2 plus c. Since y of 2 equals 0, c equals arcsine of 0 over 2 plus 2 squared over 2, which equals 2. So, arcsine of y over 2 equals negative x squared over 2 plus 2, which gives y equals 2 times sine 2 minus x squared over 2, or in parentheses. In question 3, the question states that the time taken by a coffee machine to dispense a cup of coffee varies normally with a mean of 10 seconds and a standard deviation of 1.5 seconds. There are two parts in question 3. Part A is to find the probability that more than 34 seconds is needed to dispense a total of 4 cups of coffee. In part B, after the machine is serviced, it is expected that the mean time taken to dispense a cup of coffee will be reduced, but the standard deviation will remain the same. Following the service, the mean time taken to dispense 25 cups of coffee is found to be 9 seconds each. The question of part B is to find a 95% confidence interval for the mean time that the machine takes to dispense a cup of coffee following the service. Now, let's answer part A of this question. Since the mean time to dispense a cup of coffee is 10 seconds and its standard deviation is 1.5 seconds, the expected time for making 4 cups of coffee equals 40 seconds. Accordingly, the variance for making 4 cups of coffee equals 4 times 1.5 squared, which equals 9. Since the variance for making 4 cups of coffee is 9 seconds, its corresponding standard deviation equals square root of 9, which equals 3. So PR of x is greater than 34 can be written to PR of z is greater than 34 minus 40, all over 3, which equals PR of z is greater than negative 2, which equals 0.97725. Hence, PR of x is greater than 34 equals 0.98 approximately. According to the criteria in part B, here n equals 25. The expected time for making 25 cups of coffee is 9 seconds, which sounds quite ridiculous, and I think it looks like the mean time for making each cup of coffee takes 9 seconds. So for making 25 cups of coffee, the expected time is 9 times 25, which equals 225 seconds. Meanwhile, its standard deviation of making each cup of coffee remains 1.5 seconds. Hence, the sample standard deviation is written to sigma over square root of n, which equals 1.5 over square root of 25, which equals 0.3 seconds. Since the calculation is based on 95% of confidence interval, the time interval for the mean to dispense 25 cups of coffee is from the expected time negative 1.96 times the sample standard deviation to the expected time plus 1.96 times the sample standard deviation, which approximately from 224.4 to 225.6 seconds. Question 4 is to find the primitive function which equals the integral of 3x squared plus 4x plus 12 all over the product of x and the sum of x squared plus 4 with respect to x. Before doing the integration, we need to take a close look at its integrand, which may be separate by using partial fraction technique. So it is equal to a over x plus the sum of bx plus c, all over the sum of x squared plus 4, which is arranged to a plus b, or in parentheses x squared plus cx plus 4a, all over the sum of x squared plus 4. After equating all the corresponding coefficients to those of the integrand, we have three simultaneous equations: a plus b equals 3, c equals 4, and 4a equals 12. Solving the simultaneous equations, we obtain a equals 3, b equals 0, and c equals 4. Hence, the integrand is written to 3 over x plus 4 over the sum of x squared plus 4. So the entire derivative equals the integral of 3 over x with respect to x plus the integral of 4 over the sum of x squared plus 4 with respect to x, which equals 3 times ln of the modulus of x plus 2 times arctangent of x over 2 plus c1, where c1 is an arbitrary constant.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.